Here are two of the materials that we will try to play with on the advent of the formation of the Nazi Bell Corporation. The one on the right is titanium oxide, which can be mixed with wax, formed into a concentrate. The background material is powdered ferrite. It can also be mixed with wax. We're going to let all that go right now and try to sum that up near the end of the video. This will be the first video that we're using to create funds for the Nazi Bell Corporation. We're going to go over some inventions. We're going to show one invention today known as the wireless Tesla coil. I don't think we're going to have time to go through all these inventions, but there's a list of the first 7 of them, and the 8th one is this one we're going to be looking at today. This was discovered on Halloween 2010, the 8th invention. It is the wireless Tesla coil. No transformers. All voltage beyond the alternator procured from series resonant rise of voltage. 285% better efficiency of power delivery obtained through the air versus the actual connections. Now, to demonstrate this invention then, we need to briefly go back to the preceding invention, which is the 7th invention, the 666 machine. And that is the machine that distorts time, and everyone's going to argue about that. So we got to quickly get to that, because that's our power source for the wireless Tesla coil. However, we don't need to use that for a power source, but just to demonstrate what's involved with this thing, we're going to go over here and look at the law of cosines. And the law of cosines is used to determine phase angles. And we're going to go over there and turn the machine on real quick. Earlier today, I turned the machine on, and what the 666 machine usually does is it presents 10%. It converts time into voltage rise and makes a 360-degree circle into a 395-degree one. Now, the law of cosines is pretty explicit. Once we turn this machine on, we're not going to have any load on it, and we're going to be able to stop the video at any time and apply the law of cosines to all 3 phase angles and see for yourself whether in fact there's close to 395 degrees of time separation in totality between the phasings. When we turn the machine on, we have 3 stator voltages, the small meters. We have 3 delivery lines, the large meters. And we have 3 resonant rises of voltage. And we have 3 interphasal voltage reference points. We will hook the load to one of these interphasal voltage points, and we'll go from there. There is the 9 coil assembly, if we may. Can't see all the coils. In other videos we go through all of this, and these videos will form the core of what we're offering for sale to form the Majestic 16 group of investors, 16 of them. Now then, let's turn the machine on. Quickly try to get through this. This will be this will be the first YouTube that we're going to do. And that thing keeps coming off. Okay, as we can see, this is with no field before we've energized the field. The wireless Tesla coil will not work without a field. However, because of rotational magnetism, we do get electricity out without inputting electricity to the field itself. We call this a parametric effect. Some people will call it remnant magnetism effect of the field pole face rotors. But I don't think it's remnant magnetism, and I can prove that it's not all due to remnant magnetism. We have 13.3 volts, 13.8 volts, and 12.2 volts being procured as 3 phases of resonant rise of voltage. We have the voltages between them. We have 25.78 around in there. That's 1-2. We're going to use 1-2 for our power source. 1-2 is that middle coil. We're going to take that top coil out of the picture. That top coil is what we're going to use to excite the Tesla primary. We haven't had the device hooked up yet. And if we go over here, we can see an amperage meter is on that small 2.4 Henry coil. Now, we understand that every time a load is drawn from a source, it usually drops the source voltage in this case because we're running everything from an AC converted car alternator. You don't see that kind of effect with your wall voltage because that's the power grid, and we'll let that go for now. Okay, we're going to note then, we got 20, let's note once again, the unloaded power state. Note that you can take the law of cosines and do just like I did over here. You can note the resonant rises of voltage. You can note the interphasal voltages, and you can form your phase angle by the law of cosines, and I've done that for one of the angles there, the 144.4 degree one, and in this case when we added everything up it came to 395 degrees, and the same thing should hold true for this in the unloaded state. Now it probably holds true for the loaded state, but I haven't really looked at that up yet. And what we're going to do is note we got 26 volts, and let's go ahead and put that voltage meter right next to the amperage meter. Okay, now we have down here, we have 25.6 volts. Now we're going to hook the load to it. Note that the load dropped it down to 7 volts. Quite a load there. We're drawing 14.38 milliamps. Now we're going to place another coil on top of that. That's going to be the coil that's going to wirelessly power our Tesla coil. And we're not going to be able to get through this on the first video. So we're going to take all these steps, and then on the second video go more into it. Here's that other coil behind us. Let's turn the amperage and voltage meter on. And right at this point in time, I think we're going to have to cut the video short. And what we'll do right quick away is notice what happens to the primary 14 milliamp consumption and its voltage when we put a magnetic load on it. Voltage went back up to 20 some volts, consuming 3.7 milliamps. And we're taking 15 some milliamps through the air.